All right. Welcome, everyone. Welcome to another session of Amplifying F#. For this session, we have Patrick, which is going to talk us about how can we add a compiler warning when the type checker thinks that there is an object that is inferring as a type. You can read more on our webpage, which is amplifyingf#.github.io. On here, you can read our mission statement. You can read who we are and what we're trying to achieve. But in a short note, I can basically describe Amplifying F# as a way to bring people together to fix specific issues in the F# ecosystem. If you are either a maintainer of a project and you want to take your project to the next level, and you are not sure about how to do that, you can submit a session so we can discuss, we can talk about this, and we can offer you with some alternative solutions. But if you either a contributor like Patrick today, or like myself, you want to help your open source project like the compiler, tooling, Fantomas, Fabulous, or any open source project that is F# related, you can also submit a session to basically so we can help you to get started with that and finish your contribution. So far we had a number of sessions. I can count on close to 14 sessions where we had different individuals like myself, like Jimmy, like Florian, like David, like Nicholas, like Angel, many of them. And today we have Patrick Stevens from G Research, who's going to talk us about, as I said, compiler warning when object is inferred as a type. But before we go to the session, I wanted to recap a little bit what we did last week and if our PRs or our contributions from previous session have been merged. So last session we had Ronald from Germany, and he was talking about composing state-aware functions as an alternative to objects, and he gave us a really deep down session about how can we compose a state. You can see the recording here on our YouTube channel, and yeah, you can also visit Byte, which is the project that he's working on, the library he's working on, which will enable all of this. We wanted to do a follow-up on a previous session that we had, which was a contribution to the compiler about multiple warning, improve existing warning when you try to use properties with different records that are similar. So you can see here that this was done by David, and we did it as part of the London meetup, and yeah, so it was a live stage session with Florian, with David, and myself. Florian and David did most of the job, to be honest. So most of the credit goes to them. But yeah, it was amazing. And on that, we had a contribution to the compiler that has been merged. So now for the future version, there is going to be a better error message for this, which personally I've been using the F# as well, and yeah, this was a little bit confusing, so now it will be better. So this is merged now. But for today's session, let's focus on Patrick and how can we help him to finish this contribution, that do the research and see if we can succeed with this. With that, I will hand over to you, Patrick.
Great. Let me just share my screen. Okay. Can you see Ryder now? Yes, you should be able to. Cool. Hello, everyone. I am Patrick Stevens. I'm a principal engineer at G Research. G Research is a quant finance research company. We're based in London and Dallas, and we use F# for a bunch of research related stuff. So financial markets, but in particular, one of the problems that we solve with F# is problems about transforming data. And we take, market data, for example, comes in, and we need to react to it very quickly. There is a lot of market data on in busy markets. So we've got a bunch of patterns that we have internally to make sure that, for example, we're not allocating on hot paths and so on. Try and squeeze all of the performance that we can out of the F# language. And so what we ultimately end up doing a lot of the time is a bunch of reflection up front to set up the right kinds of structures. So like we take in some nice F# types, decompose them, munge them together into like mutable things that admit much faster runtime semantics like performance. And then, so once we've spent some time at the beginning doing our setup to make stuff faster at runtime, then we're in a position to consume lots of market data very quickly. And that is the kind of place where this language suggestion comes in. So the language suggestion is number 696. And it's the proposal to create a warning for when the compiler has fallen back to inferring the type obj. So we've done a lot of data type generic programming, reflectively taking apart and putting back together these types. And often we end up in situations where we've got like a generic context that may or may not actually have inferred the correct generic type. And it's not necessarily obvious until runtime when you've got that wrong. And if something is an object runtime when you expected it to be, an int, then all kinds of things can blow up. And because we're in a situation where we've been reflexively constructing our types, we don't get any feedback from the compiler for when we've done this wrongly. So a thing that we would like to help us in this situation is to completely ban the F# compiler falling back to obj when it was unable to infer something, because that means that we should have annotated our types in general, like in our day-to-day programming. I know not everyone will have this like slightly unusual setup that has all of these strange type shenanigans. But for us, this will be useful, and certainly Don Syme, the original inventor of F#, is greatly behind this idea and would like it in. So here we are. A couple of years ago now, I put together like a proof of concept, and broadly speaking, the proof of concept kind of works, although it has some slightly odd properties. There are some tests that are currently failing, and part of what I'm here to do is to work out whether those tests should be failing or whether there's functionality that we need to fix, or we should just delete the tests. So that's the overall background of where the proposal is at. The motivating example here, I've just used the word fail with. In practice, for example, this might be like a JSON serialization. If you've incorrectly, so if you've not annotated your JSON serializing function correctly, then maybe you end up with an obj, and then the serialization will blow up at runtime, for example. But here, that's just a fail with. So the ideal outcome of this change is that we would get a warning here that there is no information available to determine what the type of A is, and so it is. So the compiler has fallen back to obj. Is that enough of an intro? If I missed anything out that anyone can spot, obviously?
No, I think it's clear.
Cool. So the pull request is this one, 13298, and I've written a bunch of nice properties that a solution would like to have. I don't yet know if the solution that I have has any of these properties, but the diff is here, and it's quite self-contained. Let's get rid of the little zoom window. And so just ignore the formatting change there. The change is actually just essentially just one file, and the rest of it is like tests and some small changes around the test harnesses. So in compiler checking type relations, we've got this standalone function choose type R solution and range, which takes in the global type checker context, like all of the information that the type checker has up till now, this mysterious abstract IL map, which I don't really understand at all, but fortunately I don't seem to have to, and a specific type parameter, which is this is a type parameter that was inferred somewhere probably, and which the F# compiler is now trying to work out, given all of the constraints that operate on this type parameter, what is the type that it should have. So before my proof of concept change, we just take our guess at the maximum type, that is the most permissive type that still satisfies all of the, sorry, the most restrictive type that still satisfies all of the requirements. And there's just this massive loop that matches on the various different constraints that are present on this parameter. And at each stage, we've taken in a constraint, and there's this magic join function that I don't really understand. I haven't looked at its definition or anything. I'm just taking it as read that it works. That kind of takes the intersection of two constraints. So what I believe was missing there by way of information that I would need to compute whether a type has been refined away from the default object is just a Boolean saying, have we done any refinement yet? And we start off, the initial state is that no, we haven't done any refinement. This is the initial type. Pass it through the fold, which is the big, no, we're going through a big loop. And there are a couple of lines where I've specifically identified that an operation has occurred, which means that some refinement has taken place. So here it turns out to be the line of code which says the type that we've got in our hand can, like for example, if just seeing if there's a useful example anywhere that can be easily explained. For example, here's the one that says in scope, does this type support comparison? Like, does the ambient context require that it supports comparison? Maybe it's a key in an F# map. So we take our existing guess and we combine it with the iComparable type constraint, and eventually that falls into this branch of the join function, and we've done some refinement at that point because we've said it can no longer be a general object, must also be iComparable. And so regardless of whether we've refined before, we definitely have refined now, and so we will update the state to true. And I've gone through the various cases where this happens and updated that accordingly. And just at the end, if we have remained at obj, if no constraints applied to this type, then I emit a warning. And a previous PR has put this warning into the massive list of diagnostics available to the compiler. So all I needed to do was refer to that. Interestingly, so this is something I hadn't thought of before. You specifically do have to check that you have a type in your hand and not a unit of measure. It would be extremely bad, I claim, for this warning to apply to units of measure, because you really don't want to find out that your integer 1 doesn't have a unit of measure, because you often don't have units of measure, so it's not useful to apply the warning in that situation. So the change in the compiler is very small. I just scrolled through the whole thing. And so we get to some tests. So new test in the component tests file, component test project. And I've just got a list of cases where I would expect it to warn. So here, for example, let f equals the Boolean test empty list equals empty list. There is nothing in scope to tell me what the type of this list is, so I would expect it to be inferred as list of obj. And that should trip my warning. Similarly, check that it works correctly in quotations, that this quotation would still experience the same warning. And here is almost exactly the example that I put on the initial language suggestion, except I've specifically used the words deserialize just to make it clearer that that's a real world time that this kind of thing arises. Similarly, if we scroll down, there are some cases where we shouldn't expect this warning. Add is special. I don't actually know how this works in the compiler, but add specifically, this plus sign will cause this function to be inferred as int to int to int. Don't know how that works. Statically resolve type parameters. So if you make this inline, then this now becomes generic, and that generic is not obj. It's not like nothing is forced to be obj. It's simply a generic function that the caller gets to instantiate. So that shouldn't warn. Similarly, an explicit generic parameter. This is just exactly the same as the previous line, but with the explicit type parameter that the compiler inferred. That one similarly doesn't want to be warned, and so on. Again, this one is a generic function. This isn't a use of obj. And you'll notice there are some to-dos throughout. Someone on the thread for this pull request asked, can we please have it so that null doesn't trip this warning? Because if you've written null, then you probably know that you've got an obj in your hand. I'm not at all sure that this will be easy. I will like briefly look at it, but probably just accept that we won't be able to do that. And that is the content. I've also made a small change to one of the helper functions for the tests just to make currying more friendly. So that's the code changes that I got so far. And this is the same branch checked out in Rider. There are some tests failing, and now we have reached the limits of my preparation. So I don't know why these tests are failing. I don't know whether they should be failing or if we should like rethink and like just delete the tests, or this functionality wasn't intended. So does anyone have anything they want to add or suggest or ask before we get started in like working out what these tests are? No?
No, that sounded
Cool.
all like good stuff. So let's get into it.
Excellent. So the first test, so this is the test that I find most like worrying, I guess. So when I wrote this test, I clearly intended there to be 3 instances of the warning. One of them is on column 30, which is this fail with. One of them is in column 45, which is this unbox. And one of them is, and another one for the result of unbox A, apparently, is what I intended. That seems like a very spammy warning if that's true, but this test is also failing. So maybe the compiler is more correct than I am here. So what are the errors that we saw? What we received was just this one on column 52. So just this one, which is referring to the entire statement unbox A. I think that is certainly one I expected to exist. Do we think it's actually correct to warn on the fail with or on just the function unbox itself? I think I am perfectly happy with it being with us just getting the 1 warning there rather than 3. I think that's probably more useful. So I'm going to claim that that is a very easy fix. It's just that my test was wrong. Let's go on to the next one. We have some member data coming in. So one of these specific tests is failing. It's the one that talks about deserialize, this one. And it turns out I've put a to-do next to it. So my test expected this to fail. I'm just going to write out this code just so we get syntax highlighting. Would be that. Yes, the value x is unused, I agree. So was I right in asserting that this should fail my test? For some reason, it has, okay, so this is an int, which is correct because that's the output of f. Let's deserialize what type of you, so Rider tells me that this type has indeed been inferred to be obj. So question is, why did the warning not fire? I guess there is nothing more to do here than just to put a breakpoint in and see what's happening. So let's go for that. So back in the code where we were performing the main loop, let's check first of all whether the warning's being emitted. That would be this line. Let's get rid of these again. Let's just refresh writer's knowledge of what tests exist. So this is the specific failing test, and let's debug it. Okay, so we have attempted to emit the warning. So this is an instance of basically why I dropped the PR after creating it some years ago. The warning has been emitted, but the associated range. So this is what the compiler is using to tell you where in your code the problem has arisen. That range is currently the default unknown. And so there are several questions. One, why is that unknown? Two, why is this causing the diagnostic to be dropped? And the answer to the latter is one that I may or may not be able to find quickly. Let's go back to the PR. And I think I linked to the specific bug. So I raised a PR that there's a test harness that we're calling in the testing code. We call type check, and this whole type check function wraps it decides what to do with any diagnostics, and it so happens that f#diagnostics.fs has probably been renamed by now. Again, this issue is fairly old, so report diagnostic. There is, I believe, some specific logic in the report diagnostic function, part of the test harness. Yeah, so it checks whether the range, checks what file the range is associated with, and if it is associated with an unknown file, then we drop the diagnostic. Is that correct? So let's show a breakpoint and see what happened. So file name was unknown, and yeah, so we pass straight through this block that this if clause that decides whether or not to surface the diagnostic to the tests. So the question is partly, how can we work around this? The question is also partly, why was the type parameter of an unknown range? I guess, unless anyone has any suggestions, I guess the easiest way to proceed would be to just set this all errors flag. I don't know whether prod will have this same problem, though. I don't know whether the fact that the test fails indicates that the F# compiler itself will also fail to surface this error. If we search for who calls this thing, maybe we can just set. Yeah, so this is, I think, specifically choosing not to surface all errors here. Let's find the stack trace. Where is the debug window? Yeah, so we're in this diagnostics handler. Okay, let's just hack this in as true and see whether we can at least get the warning. I don't know how much code this is rebuilding, actually.
This will probably build a compiler itself, so it might take a while.
Okay. While that happens, I guess, is there anything anyone would like to look at?
Is it obvious to sort of trace when the unknown name is used to create a range altogether? Was that able?
So I tried doing this some time ago. Oh, that was actually quite quick. And there we go. The warning came through when we just hacked in the enable all warnings. Let's just see what the rest of the tests do. So the question of, can we tell when we've had this fallback range? In principle, yes, it happens like all over the place though. Sadly, like there's actually a lot of type parameters floating around, and I was unable to find which ones were hitting this like default logic. I think it's like a matter of just constructing the default range type is the unknown one.
Oh, I see. Yeah, so something comes to mind that there's a way to where like a typar is created via the unchecked method, and that then probably hooks into that.
Do you know vaguely where that is?
Oof, that'd be a no, but you'll want to look for the typar.
Is this in typed tree, do you think?
Yes, might be. So yeah, that's definitely the one. I think there's a create or an empty something.
There's where we get the range, and that's from this typar ID. You would like to see empty.
It might just be the typar name itself. So the typar underscore ident or something, or ID, where that is being created. That might be the place.
There's one place that sets. No, that doesn't set it. Well, there's a useful set of naming.
Ah, yes.
There's an unchecked.default of.
Yep, stuff like that. That was what I had in mind.
And this constructs a new one. Okay, let's rerun that test and see whether we hit the breakpoint that was just hit. Is that it? How many times do we hit it? That's the question. Many times. Is it easy to tell how frequently breakpoint has been hit? I think in principle it is possible.
Oh, there was something hit count.
Is that?
Yes, there's a check hit count in the same line as yeah.
I just not suspend. So I got 1, 2, 3 instances of that breakpoint after I stopped hitting go. Basically, this is constructed many times. So it's not clear to me whether this line of investigation is going to find the answer, at least not without quite a lot of work.
Well, this is going to be created at some point, and I guess inside of your loop, we're just going to deal with one of those, and
yeah. Okay, so let's go again.
Would it be difficult to find where isRefine is actually being set to true inside the loop?
Oh, sorry, you mean in the code that in the code that I wrote around here?
Yes, exactly.
Yeah, that will happen very, very frequently. So I believe the problem is that nothing is setting isRefine to true, and that is the problem. And
right,
then,
exactly.
Then the warning is being swallowed. Enabling the debugger to trace like that turns out to be very, very, very slow. Debug outputs. Okay, so that is the number of times we constructed this thing. Lots and lots and lots of them.
It most likely happens when some assemblies are loaded and good stuff is
So I think let's probably not go down that path for now. Can I move this thing?
And so we get in here with an existing type R already, or
Yes. So our function is being called with a type parameter from somewhere. So I'll show us where I can show you the type parameter that we are correctly inferring was not. Sorry, we're correctly noting wasn't refined away from obj. Let's move this little bit of window elsewhere. So the type parameter is number 8904, if that helped.
no, that doesn't. It's just a random ID, but it is it's compiler generated is true, so that tells us something.
Let's look back at the source of what I was trying to. Let's find the test. The test code was this, and I was expecting specifically this type parameter to have been inferred as obj and to get a warning from that. Why did that test just fail is my next question, when I most recently set this diagnostic report to true. So let's find out. We did not hit that breakpoint. All errors is true. Yield the diagnostic. Who is calling us? Diagnostic collect.add. So we do now, we certainly have somehow some part of the system has raised the exception. Not the exception, the diagnostic. Let's just walk back up through the code that is checking this stuff. If report errors, then collect 1. And some side effect has probably happened that I now can't find. Let's just continue running and verify that. Doop-a-doop-a-doop. Ah, warning did get thrown. But probably just has a different string involved.
The column is slightly off. So actual is column 1 instead of column
10 is what I bet this is the to-do that I wrote saying fix this range. Hey, it is. Okay, so this is saying line 3, and it was lost the message again. So it was actually column 1. Bit strange. It's just saying that the exception, so the diagnostic was precisely on this letter L for let, but I mean I can cope with that. Just verify that this test passes.
Probably just as the start position of the parent range somewhere. So
yeah, which it's not ideal, but it's not the end of the world.
So I'm a bit confused. When the range still is line 3, then one could most likely create a proper range and just add the file name and not have to rely on the unknown name. That seems like the easy way to go with this.
Yes, it is. It's very odd, isn't it? Like, well, how come we've got a line name but no file?
Exactly.
Was it really line 3? I think it was 1.
No, the test definitely passed. Yeah. Let's just run all of them to check. The test passed when I made this change.
Okay.
Can you show, please, the checking part of the test? Because I assume this is injected in as a string somewhere, and that's why it doesn't have a.
Actual is 1, 1.
Line 1. Yes, I have wronged you. You were quite right. So yeah, it's just pointing at the start of the file then.
Okay, which is the default range, so makes sense.
So as a warning that you'd receive in prod using the compiler in anger, that's not very helpful. It just means it will just tell you that somewhere in your file there was an inference of obj. I guess we would need to track down where that range came from. which
Yes.
I don't know if anyone knows how to do that. I certainly don't.
I think we had a question from the audience. Mercury was saying if we can show. Can you repeat the question, Mercury?
All those pieces of codes are injected as strings in some checker, right?
Yep.
That's why it doesn't have a file, because we are shotgunning the compiler behavior for the tests.
Sure. So I guess we can see exactly what's happening by running one of the tests that already was known to pass and see what value the range had at that point. I think I've already got the right breakpoint in. So this is a test that passed and had a meaningful range associated with it. And so we can see what the file name is that's associated with it. That should be this M when we hit the breakpoint. So it turns out that the compiler has magicked up this test.fs file. So it's pretending that we're in a file called test.fs. Whereas in the failing test, we got unknown.fs.
That means maybe there are two passes of the compiler, right? And on the second pass, it makes up the file name as test.fs, and in our case is raising the error on the first pass somehow, and doesn't build that fake test.fs thing.
I am not sure that the file name itself is the important thing here. I think the problem is that we're getting the default range. The fact that the range is pointing specifically at character 1, line 1 is also bad. I think it would be unlikely that the compiler is doing a separate pass to discover the range of a type parameter.
If you go one level up and write the algorithm which kind of collects the type R's for the algorithm to come up with a solution. This is for some type R's not providing a range. I tried to fix it for one case last week, but this case I apparently missed. Sorry.
I mean, it's very easy to do. Like we saw the number of type parameters that were created during this test. There were hundreds. I don't suppose. Have you got any ideas for how we could track down where this thing came from? No, we've got in our hands.
It's in the unsolved. If you make a breakpoint before the loop starts, there should be like 3 or something.
Might find us in here. Yeah, there are definitely 3. I can see them. I'd like to see where they were constructed, I guess. So if we run this again. Unsolved. Right. This is all Greek to me. Okay, so we construct some kind of mutable thing. And then the debugger dies. Let's go again. So there's this mutation happens somehow.
Yeah, at the end of the accumulator functions, the unsolved will be populated.
Yeah. So after this is the unsolved. So the unsolved ones have already arisen by the end of this accumulator. So I guess we could just step through here and work out what has changed unsolved. Maybe it'll be one of these. Yeah, so there is some specific, is this the logic that you added? The specific like fallback logic here?
Yes, exactly.
Right.
But it's very possible that it doesn't catch all cases.
Right. So hopefully we can get a breakpoint there. Yeah, so here is an unsolved one.
Yeah, most probably it's something with some that bypass there.
Yeah, so
We have a sum without guardian thing, right? So the TP range is not range 0.
or the fallback range. No, in fact, in this case, it was the fallback range, which was none. There are quite a lot of calls to this thing. So here is an example where there is no fallback range. So it's possible that we are just here. Let's find the debugger. Where exactly are we? We're here, yeah. So the reason that we haven't fallen into that fallback logic is this none. I, for one, have no idea what a reasonable range would be to put in here. Is there one on the environment somewhere? There is not.
Did you expand type arcs?
This one, yep, so it's got one element. Yeah, so it is a type parameter from somewhere that has an unknown range. Just trying to see if there are any other type parameters in scope that we might be able to yank a range out of.
Be interesting to see where that one exactly was being created, I guess.
Yeah, this is all fully deterministic, is it? Will I get the number 8903 every time?
No, of course you won't.
Oh, okay.
Good
Ooh.
stuff.
Nevertheless, I will just check that. If we are very lucky, then we can just search for the number 8903. This would be the first one, which was, we were looking at the second one. So it's this one. No, this one's 8904. And we were not sufficiently lucky. Okay, so we're looking for ideas for how to track down where this type parameter came from, I guess.
Go back into the stack trace and to the point where it was somehow created, like where type arcs came from.
This is an application of something to something. Application of deserialize to something else, but there is a range here. Is this range?
Yes.
Well, I mean, this would be the easiest fix. Actually, that probably should just be a sum always, I claim. Let us that instead. Wonder, oh my goodness. Oh my. Let's just go with M throughout. What do you have? Let's stop so that we can get proper IntelliSense stuff. You must have a range. Surely you have a range. Doesn't like it to me. Maybe we need to pass a range in here as well. This one. Finally, This is the one that we were. Let's have another one. Well, that looks like it might build.
This will propagate, I guess, a lot of ranges on unit tests that might need to be dated because, you know, there was no range in the past and now.
Yeah, sure. Yeah, I'd quite like to see just whether this A catches it and B gives us a useful range out. But yeah, this may imply a whole bunch of follow-up work that should definitely be done separately from this PR.
Yeah, definitely. Yeah. I mean, as a F# user that recently, you know, couple of years with F#, one of the real frustration for me is the inaccurate ranges.
Right.
So yeah, any new range that at least is more clear than the past, I'm happy with that.
Ooh, I think this has correctly done it. So this now tells us 3.9 through 3.28. So what is that?
Better than 1.00.
So that's the word deserialize through to the call to F. So the range that we've got here is this, which is much, much more helpful. I'm perfectly happy with that range. See what all the rest of the tests do. Okay, so all of those ones pass. This one, we've got a different range now for this. Wonder why. So what range did we get? We got starting at column 30, which is this fail with, and ending at column 41, which is this. So this new range is this, which sounds perfect to me. So I have a horrible feeling this might be a non-deterministic test, actually. But 30. Because I see no reason why the change that I just made should have altered which type parameter appeared here. If this, I'll run this test many, many times at some point and we'll see whether it breaks. And the remaining failing test is the one that I've got a to-do saying, can we get it working? And I suspect we probably can't. So the idea of this was to, if we've used the explicit literal null, that is obviously an obj, can we please not warn on that? And I really don't think we have the information available to us at the time that we're doing this to work this out.
Sounds like a good follow-up story.
Yeah, I'm completely happy to just delete that without investigating further. So this is one more test to make sure that one more check to make sure that all the tests are passing, and then we can go through the PR description and see whether I've actually done everything I said I was doing. Excellent. So yeah, so the first thing I noted on the PR description was precisely that I don't know how I could disable this warning in the case of the explicit literal null. Perfectly happy to just not do that. Can I edit this? Apparently I can't edit it. Ah.
You're not logged in, so.
Now I'm logged in. Edit. Type def of. What did I mean by that? If anyone can think of an example where type def of might do an odd thing, then do let me know.
Maybe type def of underscore.
Okay, let's see what happens there. is, so we're expecting a warning here because this underscore is obj. Let's let that build and go back to the rest of this. I've claimed tests for units of measure. Units of measure being ignored is already covered by this one, I believe. Yeah. So this generic function, this generic function, generic member, has had its generic type parameter inferred as 1, but we don't cover that, so that's fine. I claim that that's enough of a test. There's the hard mode version. Compile the compiler using this warning. We can do that later. See whether that works. I've implemented the warning off by default in a separate PR. Quotations. There are some quotation tests here. There's, I think, in fact, I test everything. That is. No, I've got very few quotation tests, so possibly we should expand this a bit. And the final bit about ranges. Okay. So what was the warning? Yes, this did indeed give us an error, and that was at line 19 and 20, just to check 19 that way. That's exactly this. Ah, well, I'm happy to call that a great success.
Quick question. I imagine that this will need to be behind a lang previous session. So do you think we can update the PR to basically put a to-do there saying that this needs to be behind a lang preview session?
I don't think it does need to be behind a preview flag because the warning is already disabled by default. There's a test to make sure that it is disabled by default. So warning is off by default. Just check that with no further flags, this succeeds when we do also have a test that verifies that it fails with the warning on. So okay. Personally, I'd be happy not to hide this behind any flags. You just choose to enable it if you want.
Yeah, let's see what the team says. That they normally are really keen on putting everything on a line.
So in that case, we also don't need to worry about the compiler compiling itself.
Indeed, we don't. Yes, but I thought this would be a useful stress test. Would be if we could find all the places where this warning happens in the compiler, and check, for example, that we get useful ranges in all those cases. So the work that remains here then is to pull out the change that I made to thread through this type parameter into a separate PR, get that merged, and then this PR is basically good to go once I commit this stuff, I think. That's been very successful, unless anyone can see why I'm being an idiot.
Can we change the true to false again, just to double check?
Oh yeah, that is a good point. That's a bit of a mystery that I don't understand. Why that flag seemed to do nothing at all. Oh, are you saying that maybe this is all going to go horribly wrong when we discover that that flag is why it was all working? Where did that come from? This one. Let's go again. I do think though that now we have, like we've observed in the tests that we have ranges for all of the things under test. So I think this should continue to work.
The ranges themselves might still need some revisiting.
Yeah, sure. There's a decent chance that the separate PR that puts in the range fallback stuff will have some extra work done on it. Yeah, those tests continue to pass. I would run the entire test suite myself, except a great many of the tests currently fail for me on my local setup. I don't know why, unrelated to my change. So I'm going to have to just commit this, push it up to CI, and let the CI build it.
Well, Patrick, you have to format it, commit it, and push it to CI.
That's what I was about to say. Format.
Can I just format the entire repo, or?
Yeah, should be possible. So .NET Phantom is source -R.
Yeah, sorry. Oops, that's. I could, in hindsight, have just got the diff with master and piped those files in specifically, but
yeah,
So that is, yeah. Ideal. So I guess at some point we will see whether the CI passes on that. Then I'll pull out the change that does the fallback ranges into a separate PR. And once that's in, merge that into here and check that nothing's broken. I will probably end up adding a few more tests around quotations in particular. We've got one test here and one test further down below. Otherwise, I'm happy.
Yeah, definitely helping bring really enlightening experience, because it was about the problem. It was about trying to figure out why that the compiler was not getting the right ranges, and it was as there's a saying that says jack shaving. I don't know if you
yeah, shaving a yak, yeah. Although in fairness, we have no evidence that change has retained the stability of the compiler. As far as I'm concerned, obj inference works. I have nothing to say about how the rest of the compiler is working now that change is in.
As it's off by default, it's going to be pretty fine, to be honest.
Yeah, it ought to be fine.
One quick question. So the uncheck default underscore, is that something also that will generate a node, isn't it? It will generate that by default, if it's
like this.
Yes.
Yes, I would expect that to generate it. We can check. We can test that. And let's also add in a test that it is not when it's annotated.
Yeah, I don't see any other test on top of my head that can be apart from what you mentioned. So I call it as well a success in the terms of the session. So I mean, it's been a blast for me.
I was completely shocked that it all turned out to be so simple. I guess this is because of your previous work to identify the fallback ranges. Like if I'd been doing that on my own, I did try editing that file before, and I spent maybe half an hour on it, just passing through fallback ranges into every function and getting to a massive mess. So someone else has done all the work for me, basically. The unchecked default of didn't actually fire my warning because it fired a different warning. Because this is like the value restriction, I suppose. Yeah, it is the value restriction. I guess if I do that instead, then we would get the warning.
Yeah, definitely kudos to David and Florian. David worked on that, so yeah, it was I think when we saw that PR being sitting there for quite some time, and we saw the benefit on basically these from the day-to-day development. So yeah, kudos to you for first of all suggesting that, and for going and trying to fix that, and that's basically the aim of these sessions, to be able to work or fix something.
Yeah, off the top of my head, I have been unable to make a context in which this failed, because either it succeeded because this was actually a generic here. This was actually a generic, or it failed due to the value restriction if I did this. So I can certainly construct something, but it might take me like something I can't do right off the top of my head.
No worries. Yeah, we just wanted to mention that. But any question from the audience? Let us know.
Yeah, it's Darren here. Really enjoyed the talk, but I'm a bit of a beginner, so I just wanted to ask, what are these scenarios? What is the kind of the summary definition of falling back to inferring a null type? Is that basically where there just isn't enough information from earlier in the program or in the function?
So this is like the motivating example.
Got you.
Where
there's just nothing in there to give a type.
Exactly. So this ended up being inferred as precisely this.
Got you.
But it would similarly compile if I did this, but no longer would this trip my warning, because now I've specifically said you've been pulled away from obj.
Makes sense. So the one that threw me off was the fail width.
Yep.
That's the one that really confused me, actually.
You mean this one?
Yeah, with the fail widths, if you pick the simplest fail width scenario you've got there, why where does the null inference
This
come
one.
from in here? Yeah.
So it's not null inference as such, right? It's inferring obj.
Oh,
so,
sorry. Yeah. Sorry. Yeah.
I'll write this out. So
Oh, of course, fail with an exception
This thing.
case. There's no return.
yeah, so fail with is generic.
Yes,
This
yes,
is strictly speaking, this
Yeah.
is like a syntactic sugar for this, or a syntactic sugar for this, really.
Got you.
And we're precisely
Ah,
trying to catch the case where this has implicitly been obj rather than, for example, a, which would also be perfectly valid.
got you.
Like that turns this into a generic function.
Yeah. I see. Got you. Okay. Thank you.
Mhm.
Yeah. Sorry, there were just a few of those edge cases I couldn't work out what was the fault. Thank you.
Yeah, no problem.
Any other question? Perfect. From the Amplifying HR team, thank you very much, Patrick, for raising this PR, working on this contribution, and yeah, we're really
No problem.
happy to have you here.
Yeah, thanks very much. No, this was helpful just because it's good to have access to the people who have the expertise. Like there was a bunch of small questions that I had that people just knew the answer to, so that helped.
Definitely, we're here to help you. So anything that in the future that you want to contribute to the compiler, and you want a audience to work on, it's perfect.
Cool. Thanks very much.
Cool. That's it from today's session. So if you don't have any other question, please, if you want to contribute to your open source project, you want to fix a specific issue on the F# ecosystem, please create a session on the Amplifying F# webpage that I will share my screen and quickly show you. But let me check where is the meeting here. So I got this one. Okay. So hopefully I'm sharing my screen. So yeah, so Amplifying F#, go to our webpage and submit the session. For that, you just need to join us. On here, you will fill a form. We're telling us what's your name, your company, the time zone, and the topic that you are trying that you want to cover. If it's a specific issue like this one, or you want to work in a specific project, or if you don't know still what you want to do, but you want to still have an idea what, just tell us, and we will schedule the session and we will, come back to you